Um, okay.
Welcome to Thermtest Asia. Today we're going to take a quick tour from the front entrance to the laboratory and do a demonstration on transient plane source. So follow me. So here is the Thermtest Asia demonstration laboratory. Today we'll be talking for just a few minutes on asymmetric or single-sided testing with the transient plane source, both the MP-1 and the MP-2. Tradition here, same as in Taiwan as it is in Canada. We'll do a quick turnaround and show some of the equipment they have here for demonstration. Before we talk about the MP-2, here is the THW-L2 for measuring liquids and phase change materials by ASTM 7896, and HFM25 for measuring insulation materials by ASTM C518, especially focused on small format materials. The ideal size is a couple inches square by up to 1 inch thick. And here is the larger HFM100 following ASTM C518, as well as the associated international standards. This size is 300 by 300 by 100 millimeters thick. We have another size, which is the HFM50, which is 200 millimeters by 200 millimeters by 50 millimeters thick. And there is a new high temperature version. The temperature range for the HFM100 and the HFM50 are minus 20 to 75 Celsius. Of course, that's the plate temperature. The actual mean temperature is based off the delta T that you put on each side of your sample. The HFM100 high temperature goes from minus 30 to 110 Celsius. So that is the HFM100. So it's the big brother to the HFM25. So this is the MP1, and this combines several methods. This is our marquee transient method. One of the key features of the MP1 is as a multi-channel port for measuring more than one sensor or more than one method at a time. And each method has the ability to measure those properties with temperature. So the main methods that were just mentioned today are the transient plane source method, which is ISO 22007-2, and the transient hot wire, which is ASTM 7896 for measuring liquids. For both methods and types of materials, thermal conductivity, thermal diffusivity, and volumetrics to the heat. So today we're going to talk a little bit about one of the common questions I get is, what is the difference between asymmetric and symmetric testing? And can the MP1 and the TPS2 measure both asymmetric and symmetric? And the answer is yes. The MP1 and both the TPS2 are able to measure the configuration where the sample is on the bottom and the top, as well as the configuration where there's a known material on one side and your unknown is on the other side. So if we come in here, we can show a basic configuration. Of course, the sensor is already inserted. We have lots of demonstration videos that show how to hook up a sensor. But the configuration for asymmetric, we're going to use this XPS as the known material. How do we know what the values are for this method? Is because we can measure them. So we can actually set up two pieces of XPS and measure the thermophysical properties. So for the thermal conductivity and thermal diffusivity, that acts as the known material. And then in this case, we're going to measure glass, is our unknown material. We place it on top, and then we place a material on top just so we're not scarring our sample. And we lower the top bar down and just finger tight compresses the sample against the sensor and the insulation. Now, if you were doing symmetric, you would have a piece of glass on the bottom and a piece of glass on top. So we'll just briefly show the software. This is the configuration. We've picked 3D disk source, asymmetric, which tells the software that we're measuring single-sided, and it's a semi-infinite body. So we'll go to next. We're going to do a room temperature measurement on channel 1, which is the front of the instrument. I've already pre-named the sample glass. The backing material is XPS, and these are the dimensions of the sample, both the sample height and the sample radius. And over here, we've asked the ITPS to tell us what's the ideal sensor to use. I've clicked the sensor, which is to confirm that the electrical contact is good. The temperature range is taken right from the sensor adapter. And these are the parameters that the ITPS guided us to select. So if we go to next, we can basically set up a 5 measurement test with a 10-minute delay of 20 seconds and 50 milliwatts. So by clicking start, we can set up the schedule to run those automatically. So let's leave the MP-1 and we're going to go over to the MP-2, and we'll actually do the rest of our demonstration here. The single-sided sensor, the TPS4 sensor, which is available on the MP-2, is the identical configuration with the exact same sensor diameter to what we just demonstrated on the MP-1. Difference being, it's permanently housed in a sample housing. So underneath that, if you were to cross-section this away, underneath that sensor, which is on top of that raised area, is the same diameter sensor, which is 6.4 millimeters radius, and underneath that is a piece of XPS. That is our known single-sided setup for the TPS sensor that's available on the MP-2. So what does that enable us to do? That enables us to measure thermal conductivity from a range of 0.03 up to 5 watts per Kelvin. So the configuration for the TPS sensor is a sample on top, like that, with a weight, and your minimum sample size for this size sensor would be approximately 30 millimeters diameter or square. Of course, your sample can be any shape as long as it's at least 30 millimeters diameter and thickness 4 or 5 millimeters thick. The other configuration is sample on the bottom and sensor on top, like this, where you use a weight to create contact with the sample. This is often the most convenient way of measuring large materials that are hard to configure. So for demonstration purposes, there's a little bit more to see when you place the sample on top. Here we can show the screen. So this is the MP-2, which we have connected to the wall for power. We can of course draw the power from the computer as well, or batteries, so you can have it completely remote. When you plug in your sensor, and as you know from the other demonstration videos, the MP-2 has a THW sensor for liquids, a TPS sensor for solids, and a range of other sensors that you can use to expand the ability. So when you're ready to make a measurement, you push start, and it does a temperature drift recording for a length of time before the measurement. That's just to ensure that the room temperature here in our lab is stable. What would create drift is if there was an air conditioner blowing directly over the sample. We want to make sure that's the case, and that actually shows a little bit of trend, so we could see some effects of that. So now we're making a measurement of transient versus time. We see a little bit of clipping only in the screen because it doesn't auto scale, so we can review that, and of course you'd see a proper transient, but there is a temperature rise versus time that matches. You're just seeing it run out of the screen, and there's our thermal conductivity for glass. And if we want to review that, we can go to view data, and you can see we've tested some rubber. We'll go to glass, and we can see our graph. There's our residual pattern, and that residual pattern shows that we have a good fitting and good results. And we can go back to home, and there's our thermal conductivity for glass. So that's all we really wanted to demonstrate briefly, was the ability to measure by single-sided or asymmetric configuration for TPS, both on the MP-2 for a much more narrow range. We have a very intelligent meter we've designed to be able to take advantage of the multi-sensors that are available. But that same capability and much more capabilities available on the MP-1. Thanks for joining Thermtest Asia Demonstration Corner, and we look forward to other demonstrations. Get in touch with us if you have any questions. Cheers.